our in-text question from the lesson Electrochemistry. How would you determine the standard electrode potential of the system Mg2 plus / Mg? If we want to measure the standard electrode potential of any electrode, we have to connect that with a standard hydrogen electrode that is taken as the reference half cell, that is taken as anode, and magnesium / Mg2 plus / Mg, that is taken as the cathode. So let us represent the cell as Pt / H2 / H plus double vertical line Mg2 plus / Mg. From the measured E0 value, we can see E0 cell, we can calculate the E0 value or reduction potential value of the magnesium electrode. In this case, the E0 value or reduction potential value of magnesium will be negative. That indicates that magnesium can reduce hydrogen ions because magnesium is more reactive than hydrogen ions. Because of that, we will get the reduction potential as negative. Can you store copper sulfate solution in zinc pot? We know zinc is more reactive than copper, so we cannot store copper sulfate in zinc pot because zinc will displace copper from its solution. So we can write the equations Zn plus CuSO4 gives ZnSO4 plus Cu. So zinc will go into solution and copper will be precipitated. Consider the table of standard electrode potential and suggest 3 substances that can oxidize ferrous ions under suitable condition. So oxidize means oxidizing agent, they should undergo reduction. So their potential should be more than the potential of ferrous ions. So hydrogen, copper, silver are examples of this. We can choose anyone whose potential is more than the potential of Fe, iron metal or ferrous ions. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. So pH is equal to negative log concentration of H plus. That can be written as plus log 1 by concentration of H plus. So pH is given as 10. Now let us write the reduction equation for hydrogen electrode, that is H plus 1 electron gives half H2 gas. Now let us apply Nernst equation for single electrode. EH plus / half H2 is equal to E naught H plus / half H2 minus 2.303 RT by NF log 1 by concentration of H plus. E naught H plus / H2 is equal to 0 volt. 0 minus 2.303 RT by F, that value is a constant. That is, when we multiply 2.303 into 8.314 into temperature 298 and Faraday's constant 96,487. So when we multiply and divide with these values, we will get 0.059. And N is a variable that depends upon the number of moles of electron, that is 1 electron, log 1 by concentration of H plus is given as 10, that is the pH. So from that minus 0.059 into log 10 is 1. So we will get minus 0.059. So that much volt. Calculate the EMF of the cell in which the following reaction takes place. Ni plus 2Ag plus gives Ni2 plus 2Ag. So according to Nernst equation, we can write E cell is equal to E naught cell minus 0.059 by N log concentration of Ni2 plus by concentration of Ag plus the whole square. Here Ni is changing to Ni2 plus 2 electrons. So number of moles of electron involved is 2, and 2 Ag plus 2 electron gives 2 Ag. So N equal to 2. N equal to 2. E naught cell is given in the question. So 1.05 minus 0.059 by 2 log concentration of Ni2 plus is 0.160 divided by concentration of Ag plus is 0.002 the whole square. So that will be 1.05 minus 0.0295 log 0.160, we can write 160 into 10 raised to minus 3 divided by denominator 2 into 10 raised to minus 3 the whole square, that is equal to 4 into 10 raised to minus 6. So when we simplify, we will get here 40, and 10 raised to minus 6, when we take to the numerator, it will be plus 6, and we will get 40 into 10 raised to 3. That is equal to 1.05 minus 0.0295 log 40 into 10 raised to 3. Log 40 is 1.6021 and log 10 raised to 3 is 3. So we will get 4.6021. So 1.05 minus 0.0295 into 4.6021. So when we simplify this, we will get 0.137, or we can write 0.14. So when we subtract, we will get 0.91 volt. The cell in which the following reaction occurs: 2Fe3 plus 2I minus gives 2Fe2 plus I2, has E naught cell 0.236 volt. Calculate the Gibbs energy and equilibrium constant of the cell reaction. Gibbs energy means delta G naught. So standard Gibbs energy, that is equal to minus NF E naught cell, where N is the number of moles of electron involved in the redox equation. So 2Fe3 plus is changing to 2Fe2 plus, that is Fe3 plus is undergoing reduction. So let us balance the equation by adding the electron. Similarly, 2I minus gives I2. Here number of moles of electrons involved is 2. So N equal to 2. So delta G naught is equal to minus 2 into Faraday's constant is 96,487 coulomb, but we can take it as 96,500 for calculation. So 96,500 into E naught cell is given in the question as 0.236 volt. So when we simplify this, we will get minus 45548 joule per mole. Now delta G naught is equal to, for calculating the equilibrium constant, we can write delta G naught is equal to minus 2.303 RT log K. Here K is the equilibrium constant. So log K is equal to delta G naught divided by minus 2.303 RT. Here delta G value is negative, that is minus 45548 divided by minus 2.303 into R is 8.314 and temperature is 298 Kelvin. So when we simplify this, we will get 7.983. 7.983. So K is equal to anti-log of, log K is equal to 7.983. So K is equal to anti-log of 7.983. So that is equal to anti-log of 0.983 is equal to 9616. So after one place we can put the decimal, then characteristic part is 7, so into 10 raised to 7. So 9.616 into 10 raised to 7. Why does the conductivity of a solution decrease with the dilution? We know conductivity is the conductance of unit volume of solution kept between platinum electrodes of unit length and unit area of cross section. So when we dilute the solution, the number of ions per unit volume decreases. As a result of this, conductivity of a solution decreases with the dilution. Suggest a way to determine the limiting molar conductivity of water. According to Kohlrash's law, the limiting molar conductivity is the sum of the individual contribution of cations and anions. So lambda m0 H2O is equal to lambda 0 H plus lambda 0 OH minus. This is our required equation. So we can prepare H2O by adding NaOH and HCl. The neutralization reaction we know NaOH plus HCl will give you NaCl plus water. So if you take the sum of the limiting molar conductivity of NaOH and HCl, from that if we subtract the limiting molar conductivity of NaCl, we will get the limiting molar conductivity of water. So lambda 0 NaOH is equal to lambda 0 Na plus lambda 0 OH minus. Let it be equation 1. Similarly, lambda m0 HCl is equal to lambda 0 H plus lambda 0 Cl minus. That is equation 2. And lambda m0 NaCl is equal to lambda 0 Na plus lambda 0 Cl minus. That is equation 3. Then 1 plus 2 minus 3 will give you lambda m0 of H2. That is equal to lambda 0 Na plus lambda 0 OH minus plus lambda 0 H plus lambda 0 Cl minus. Then we have to subtract lambda 0 Na plus minus lambda 0 Cl minus. So minus Cl and plus we can cancel, minus Na and plus Na we will cancel, so that we will get lambda 0 H plus lambda 0 OH minus. That is the limiting molar conductivity of water. Suggest a way to determine the limiting molar conductivity of water. According to Kohlrash's law, the limiting molar conductivity is the sum of the individual contribution of cations and anions. So lambda m0 H2O is equal to lambda 0 H plus lambda 0 OH minus. This is our required equation. So we can prepare H2O by adding NaOH and HCl. The neutralization reaction we know NaOH plus HCl will give you NaCl plus water. So if you take the sum of the limiting molar conductivity of NaOH and HCl, from that if we subtract the limiting molar conductivity of NaCl, we will get the limiting molar conductivity of water. So lambda 0 NaOH is equal to lambda 0 Na plus lambda 0 OH minus. Let it be equation 1. Similarly, lambda m0 HCl is equal to lambda 0 H plus lambda 0 Cl minus. That is equation 2. And lambda m0 NaCl is equal to lambda 0 Na plus lambda 0 Cl minus. that is equation 3. Then 1 plus 2 minus 3 will give you lambda m0 of H2, that is equal to lambda 0 Na plus lambda 0 OH minus plus lambda 0 H plus lambda 0 Cl minus. Then we have to subtract lambda 0 Na plus minus lambda 0 Cl minus. So minus Cl and plus we can cancel, minus Na and plus Na we will cancel, so that we will get lambda 0 H plus lambda 0 OH minus. That is the limiting molar conductivity of water. The molar conductivity of 0.025 mole per liter methanoic acid is 46.1 Siemens centimeter square mole raised to minus 1. Calculate its degree of dissociation and dissociation constant. So, degree of dissociation alpha is equal to lambda m by lambda m0. Here lambda m is the molar conductivity and lambda m0 is the limiting molar conductivity. So lambda m is given in the question as 46.1 Siemens centimeter square mole raised to minus 1. Lambda m0 of methanoic acid is equal to, according to Kohlrausch's law, it is the individual contribution of cation and anion. So here we have lambda m0 HCOO minus plus lambda 0 H plus. So lambda 0 HCO minus is equal to 54.6 and lambda 0 H plus is equal to 349.6. So when we simplify, we will get 404.2 Siemens centimeter square mole raised to minus 1. Now degree of dissociation is equal to lambda m by lambda m0. So lambda m is 46.1 divided by 404.2. So when we simplify, we will get the degree of dissociation as 0.114. Now for calculating dissociation constant, K is equal to C alpha square by 1 minus alpha. Here C is given as 0.025. So let us substitute. So that is equal to 0.025 into alpha square, that is 0.114 square, divided by 1 minus 0.114. So when we simplify this, we will get 3.67 into 10 raised to minus 4. If a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons flow through the wire? So Q is equal to IT, that is current into time. Current is equal to 0.5 ampere. Time here it is given in hours, so we can convert into seconds. 2 into 60 into 60. So 0.5 into 2 is equal to 1. 1 into 60 into 60, that is 3600 coulomb. Now we know the charge of 1 mole of electron is equal to 96,500 coulomb. 96,500 coulomb is equivalent to 1 mole electrons, that is 6.022 into 10 raised to 23. So 1 coulomb is equal to 6.022 into 10 raised to 23 divided by 96,500 electrons. That is, we have 3,600 coulomb So that is equal to 6.022 into 10 raised to 23 divided by 96,500 into 3,600 electrons. So when we simplify this, we will get 2.246 into 10 raised to 22 electrons. This is the number of electrons passing through the metallic wire. Consider the reaction Cr2O7 minus plus 14H plus 6 electron gives 2Cr3 plus 7H2O. What's the quantity of electricity in coulombs needed to reduce 1 mole of Cr2O7 minus? Okay, we have taken 1 mole of Cr2O7. From the equations we can see 6 moles of electrons are required. That is, charge of 6 moles of electron is 6 Faraday. That is in coulomb 6 into 96,500 coulomb. That is equal to 5,79,000 coulomb of electricity is required for the reduction to Cr3 plus. Write the chemistry of recharging lead storage battery, highlighting all the materials that are involved during recharging. So during recharging, we know the electrical energy is supplied to the cell from external source and the cell is working like an electrolytic cell. So in the case of cathode, we have written the opposite reaction. So PbSO4 plus 2 electron will give you Pb plus SO4 2 minus. Then anode PbSO4 plus 2 water will give you PbO2 plus SO4 2 minus plus 4H plus 2 electron. When we add both the equations, we will get 2 PbSO4 plus 2H2O gives Pb plus PbO2 plus 2SO4 2 minus plus 4H plus, or we can write 4H plus and 2SO4 2 minus together as 2H2SO4. Suggest 2 materials other than hydrogen that can be used as fuel in fuel cells, methane and methanol. Explain how rusting of iron is envisaged as setting up of an electrochemical cell. At a particular spot of an object made up of iron, oxidation takes place and that spot behaves as anode. So Fe is undergoing oxidation to Fe2 plus 4 electron. The electron released at anode spot, it move through the metal and go to another spot on the metal and reduce oxygen in presence of H plus, and this spot will behave as cathode. O2 plus 4H plus 4 electron will give you 2H2O. So let us add both the equation and we will get the overall equation as 2Fe plus O2 plus 4H plus electrons we can cancel, then we will get 2Fe2 plus 2H2O. Now we got the ferrous ions. These ferrous ions are further oxidizing by atmospheric oxygen to ferric ions, and this ferric ions, when it comes in contact with the moisture, we will get the hydrated ferric oxide Fe2O3 dot XH2O. So let us write the atmospheric oxidation of ferrous to ferric as 2Fe2 plus 2H2O plus half O2 gives Fe2O3 plus 4H plus. And this Fe2O3, when it reacts with the moisture, you will get Fe2O3 dot XH2O. That is the rust.